Hello and welcome. My name is Travis Benson. I'm a student at Washington State University in food science and management. I'm here doing a presentation on a topic review of novel seaweed fermentations intended for human consumption. Seaweed is being now thought of as a greater source for human food for many reasons. One, because of the environmental benefits. There's no land needed, no fresh water needed, no fertilizers or pesticides needed to grow it, and it fights ocean acidification as well as sequestering carbon. Secondly, are the nutritional benefits. It's a great source of protein for certain species, and as well as a good source of omega-3 fatty acids and vitamins and minerals. All of these things make it very appealing to add into a regular diet in the future for humans. Traditionally, there is seaweed in the food industry, mainly in Asian cultures. There is dried nori sheets, dried kelp sheets, such as kombu. And in the American food manufacturing, as well as the world food manufacturing industry, there is agar-agar usage, as well as sodium alginate and carrageenans, all are extracted from seaweeds. Using various purposes such as jellification, stabilizers, thickeners, and emulsifiers in the food manufacturing industry. This study's focus is on the newer products being designed using the fermentation of seaweeds for human consumption, such as nori shoyu, as well as fermented beverage products. Nori shoyu is a shoyu style sauce made with 100% nori instead of any soybean or wheat substrate. And fermented beverage product is a drinkable tonic made out of fresh seaweed fermentation. First, we'll talk about nutritional composition in relation to the fermentation of the two types of seaweed used. There is rhodophyta, or red seaweeds. The species are ogo and nori that we'll be discussing, which have high protein contents. Most of the nutrition we're going to be talking about is only important for fermentation, so we won't go hard into it. But the protein contents are 20 to 33% on average, and for nori can go as high as 57%. The rhodophyta also have a very low fat content. The phyophyta, or brown seaweeds, such as oarweed or kelp, will be the names of the ones we are dealing with in our topic review, have lower protein contents, 14 to 15%, but importantly, high carbohydrate contents of 75%. The carbohydrates are fucoidin and laminarin that are very interesting as far as fermentation goes, and we'll discuss those further down when we get to the fermented beverage products. First, we're talking about the nori shoyu. It was originally thought up by a Japanese fisheries scientist as he was cleaning his refrigerator and found a container of 18-month-old nori that had rotted and fermented in his fridge. He removed it, and in disposing of it, caught whiffs of some umami-like sense that he thought was interesting, and he began his idea to create a seaweed sauce out of that. So the first time he attempted it seriously in 2013, he was isolating halophilic strains of lactic acid bacteria. He attempted it on chlorophyta, phyophyta, and rhodophyta, or green, brown, and red seaweeds, finding that the halophilic strains grew very well on the nori. He treated nori with protease and salted that by 15% wet weight for a pre-treatment enzyme metabolism step. Then he inoculated those pre-treated nori seaweed with samples of bacteria collected from 25 different environments across Japan. 6 of those samples showed growth of Tetracoccus halophilus, as well as 10 different species of that. The 2 species that were chosen as starter cultures was DSW1 and SNW1. They were chosen because of their abilities to grow in extreme environments, selected from 400 meters below sea level in a mesopelagic lake, and from an alpine glacier 2,500 meters above sea level. Then he went forward with the initial characterization of fermented seaweed sauce. Again, there was a pre-treatment step utilizing proteases, peptidases, and manases, this time with a 20% wet weight salt pre-treatment. It was let metabolize for 24 hours before the inoculation of the T. halophilus starter culture, and then let ferment for 2 years at 23 degrees Celsius prior to a 90 degrees Celsius 20-minute heat treatment step to make the product shelf stable and stop any activity. This was taste tested. The results are in a separate slide, but before then I wanted to discuss the last attempt he made to create a more efficient commercialization process for the seaweed sauce. Aspergillus oryzae was isolated for its proteolytic functions to be utilized on the nori. This Aspergillus oryzae helped to speed the fermentation up to 167 days prior to the 2-year fermentation. It also consequently allowed for 30% more products being extracted from the moromi, or nori and water mash, as it would be seen. The two lactobacillus species and important metabolites coming from them, or the lactobacillus species and Aspergillus oryzae, and the metabolites coming from them are discussed below. Interestingly, T. halophilus, has the ability to live in high saline environments because of its extracellular transport ability and intracellular synthesis ability of low molecular weight ions. These are brought into the cell cytoplasm to counteract the turgor pressure loss, which will then prevent the death of the cell through desiccation. It also can counteract freezing and heat death, as well as oxygen radical death. The Aspergillus oryzae is known for its protease and peptidase production and is a prolific creator of the glutamate, L-glutamate metabolite from the nitrogen metabolism cycle, and nitrates in particular. Nitrates are the nitrogen form most found in plants, which makes them excellent for creating the umami flavor, which is the glutamate in a seaweed soy sauce. The taste test results were as follows. The seaweed sauce had a lactic acid levels of 62 milligrams per 100 milliliters, which was higher than the soy sauce that it was compared with, as well as lower than an anchovy-based fish sauce that it was compared with. Seaweed sauce also had higher levels of free peptides when compared to soy sauce, but the fish sauce was not tested for that and was not able to be compared. The seaweed sauce had lower levels of free amino acids than soy and higher levels than fish sauce. As metabolites go, important metabolites for the umami flavor that was intended to be produced, the L-glutamate and aspartic acid counts were more similar to fish sauce than soy sauce. Aspartic acid provides a bitter umami flavor that is not characterized in soy sauces nearly as much as fish sauces. Here is a production process flow chart to organize all of the different processes that have been developed to streamline a seaweed-based shoyu in an organized fashion. A fermented seaweed beverage is being produced in Ireland and in Thailand. We'll deal with the Irish fermented seaweed beverage first. They are using Laminaria digitata as well as Laminaria saccharina as their species of fermentation, pictured below. The raw samples were tested, as well as a heat-treated set of samples were tested. No fermentation was recorded with the raw samples, even with an inoculation of L. plantarum. This is theorized to be from the high presence of fucoidins, which would block the motility of L. plantarum because of their structure, and also the fucoidins are a fucose-based sugar, The backbone is fucose, and then there are many arms of a sulfur containing ester, which inhibits the L. plantarum fermentation and growth. During heat treatment, it seems this was not a problem, as rapid growth was observed from hours 3 through 15 and up to 24 hours until growth ceased. The other interesting aspect is that at 0 RPM, there was more lactic acid production, thought to be because of the aeration, thought to be because there was less aeration or no aeration at 0 RPM. With aeration, there was acetic acid observed, giving it a much more fermented, vinegary flavor rather than fermented flavor. The Thai seaweed beverage followed a traditional fermented plant beverage ratio of 3 parts plant, 1 part sugar, and 10 parts water with a 5% starter culture. The starter culture chosen was L. plantarum again. This time it was utilized because it is able to produce GABA or gamma aminobutyric acid at high levels. It was fermented for 2 months in the study, although it has been quoted as 2 to 6 month fermentations at 30 degrees Celsius. They also added 1% by weight MSG into a pre-treatment phase to increase the amount of GABA being produced, since GABA is a metabolite of glutamate metabolism. The intended use of these are nutraceuticals, as the ability of GABA to de-stress as well as create hypotensive abilities or hypotensive reactions and neurological benefits have been shown in many studies. So in conclusion, they both offer interesting food for human consumption products from fermented seaweed. Nori sauce's place would be an allergen-free, grain-free fish sauce replacement. Has a higher mineral and vitamin content than fish and soy sauce, but has the hurdles of long fermentation times at a minimum of 167 days, as well as an expensive substrate in dried nori. The fermented seaweed beverage has quicker fermentation times of 24 hours to 2 months, depending on what style you're using, the Irish or the Thai. Has a cheaper substrate because the product is not dried, and the potential function as a nutraceutical as a product on the market. The addition of 1% MSG did show high levels of GABA production, but the negative effect was the flavors were deemed unpalatable for taste testing. So that would be not recommended if that style was being utilized. Thank you so much for watching my topic review. I hope this was interesting, and you have a good day.